Continuando con el programa, invito al doctor Carlos Jaime Barrios, quien va a presentar la siguiente ponencia, el caso de estudio de nuestro sponsor ThinLinc. Por favor, ingeniero Carlos Jaime, si es que nos puede confirmar.
Yes, thank you very much, Francisco. So, very pleasure to present Henrik Bilar by the side of Sendio. Henry is one of the developers and Linux administration and DevOps of this company. And Henrik shared with us the different case of study that is made by Sendio ThinLinc, this important tool that maybe here in Latin America we are very interested. Henrik is his institute was in the Open University and BGC in open development, and a master's degree in the Birkbeck University of London in computer science. So thank you very much, Henrik, and please.
Thank you. Okay, let me try to share the screen. Let's see if that works.
Mm-hmm.
Cool. Can everyone see this?
Yes, perfect.
Okay, great. Okay, so I don't actually work for Sendio. I work for a company called Man Group, but we run a lot of ThinLinc clients. So I will talk you through our little setup and how it works. So first of all, Man Group is an active investment management firm. We have $108 billion under management at the moment. We run mainly quant strategies, i.e. we write software that makes trading decisions for us. Man Group itself consists of 5 hedge funds, and we have presence in 4 continents, and we employ roughly 400 researchers and technologists. And basically everything we write is written in Python, apart from some very time-sensitive things that we use C for and Java. And everyone who works for Man Group really knows at least a little bit of Python, including people who wouldn't necessarily be in technology. So myself then, I'm a staff engineer in the quant infrastructure team at Man AlphaTech. So AlphaTech is a subdivision of Man Group, of course. I've been working with Linux and other Unixes for more than 20 years now. And as the presenter mentioned earlier, my latest educational experience is an advanced computer science MSc from Birkbeck University in London. My current interests at work are mainly focused around automation and around Kubernetes. And in the automation space, I mainly play around in Ansible at the moment, although because I'm an old Unix person, I still use a lot of Bash, and we also write a lot of Python to automate simple things. So anyway, so our tech stack then at Man Alpha, the hardware-wise, we run a large estate of HP and Supermicro machines. We have about 6,000 cores in total and about 75 terabytes of RAM for our researchers. Storage-wise, we have, of course, local SSD in all the machines, but we also run flash array and FlashBlade technologies from Pure Storage. The FlashBlade in particular is great. We get S3 and NFS through the FlashBlade, and it handles as many IOPS as we have ever managed to throw at it, including running large Spark simulations. So we regularly read and write more than 15 gigabytes per second to it. For virtualization, we use OpenStack and VMware. Primarily VMware would be used in pre-production and production, and OpenStack on the development and research side. And the way we provision compute to our users is that everyone gets their own virtual machine in OpenStack, and they run a Linux desktop in there, which we then serve to the user using ThinLinc. So as a user at Man, you would typically run all your strategies and simulations would be done in Kubernetes or run on Docker on bare metal, or indeed in bare VM, as it were. All our new development now goes into Docker containers so that we can easily migrate workloads between, well, different clusters, first of all, but also DR and those kind of things become really simple because we can move like a lump of software and everything just works exactly the same. For data storage, we use a lot of MongoDB because it seems to be one of the fastest platforms we can get at the moment. We've also written our own tick store where we store financial ticks from markets. It's called ArcTick and it's open source. It has quite a large user base by now, not just Man Group, but other financial organizations also use that. And then we have a list of sort of usual suspects that you would expect to find in sort of the quant type companies. So we have Spark, of course, we run Jupyter notebooks, a bunch of Jenkins for builds and ad hoc jobs, and we also write a lot of custom in-house software, as I mentioned, in Python. And I think I mentioned already that all our strategies and all our research is developed in Python. Yeah, so the way that would work then is that a researcher would play with data in Mongo and ArcTick, and they would come up with a strategy that works, and then a developer would take that Python code and basically productionize it so that it runs properly in production and is unit tested, etc. On the quant infrastructure side, we have, like mentioned earlier, we have a lot of servers, but there's actually only 5 full-time Linux engineers at the moment. So we have a small team and we have lots of servers spread across a large geographical area. And we also have lots of users that we also support. So we need decent automation tools in effect to be able to manage this workload. So we use Kubernetes at the moment. We've been using that for a couple of years now. We tried many years ago already to move to Kubernetes, but we found it very difficult at the time, which is how we ended up with Docker on bare metal. But now we've finally managed to get that working all the way up to production. So we now run some strategies and some trading through Kubernetes. We also use a lot of Ansible, which is great for pushing out configuration or doing those kind of sort of repetitive tasks that we would typically maybe have used Bash for, or Bash and SSH. We now run in Ansible because again, it becomes easier to manage the code, and we can check it into a Git repo, and we can pull requests and all that kind of good development stuff. For provisioning VMs, we use Terraform. So Terraform is a HashiCorp product, which lets you basically provision VMs in different cloud environments or virtualization environments. And for example, we use the same Terraform code, also checked into Git, but the same code is used for provisioning VMware and OpenStack without us having to make any changes, so to speak, between going from different environments. We also create a lot of Jenkins ad hoc jobs that our users can run if they want to do some self-service things, and we also use it as a cron scheduler. All the kit we buy at the moment and all the software we buy as well, one of the main requirements is that it has an API, because without an API we can't adequately automate the environment, and if we can't do that, then it means that we have to we would basically need more people to run our environment. So obviously I'm talking about ThinLinc today, so that is about delivering the desktop experience to the users, so to speak. And this slide is all about how we got to choosing ThinLinc, really. So back in the day, we used to use No Machine on Red Hat 5. And when we started implementing CentOS 7, we didn't just switch operating systems, we also switched like the provisioning of or delivery of the actual desktop. So we had some requirements there, of course. It had to be easy to maintain, and it had to be fast and stable. The stable here refers to, like, we had some issues with a lot of VNC servers, for example, where they would work to a degree, and then occasionally, for example, GNOME does some odd X call, a weird X call, and it crashes the VNC server. And we tested a whole bunch of VNC servers, and they share a lot of code, so they all had the same bug. And the only one we didn't manage to crash in the end was ThinLinc. And we also need to be able to reconnect the sessions. So typically our users will run, like, they will be logged on to their desktop environment for maybe a month at a time before we reboot a machine or they reboot a machine. So being able to reconnect your session from either from the office or then going home and work from home for a bit. Being able to reconnect to the same session is very important to us. And you can see there on the slide the software we tested. X2Go had a lot of promise, but then in the end we settled for ThinLinc mainly due to stability issues, and also it has tools around it to let us manage or easily train users to connect to the right place. So why did we choose ThinLinc then in the end? It's the fastest of the VNC equivalents we tested. Certainly for things like streaming video, it is much faster than a lot of other VNCs. And also the interactive performance is pretty good. It's also the most stable one we found, so we didn't have any random X-error crashes. Zendio itself, even before we bought the product, they were really quite quick in responding to our support requests, and they seemed like a nice company to deal with. They all seem to be techie people, which suits us really well. It is possible to automate the install with some caveats, and it was a reasonable cost as well. So obviously we tried all the free options first, but then we realized we might have, if we paid some money, our users would have a slightly better experience. So how do we actually make ThinLinc available to our users then? Basically, when we build a new server or a virtual server for a user, the typical workflow would be that we boot a server, some Ansible gets run, and then the server becomes available for the user with everything configured. So the way this happens is that we create some Terraform code, which is committed into Git using a job in Jenkins. And the same Jenkins job raises a pull request, and someone verifies the pull request, and then we merge the pull request. And when the pull request is merged, we then have another job that uses Terraform to actually build a server, and it generates some keys and tokens in our HashiCorp Vault and console. So Vault, for example, Vault is a product where you can store passwords, and it does password management for you in a reasonably secure way, or in fact a very secure way. So anyway, so Terraform builds a server, like it starts the server up, it creates all the disks, etc., and then it boots it up. And on first boot, Ansible will then run automatically, and it will get the credentials we created in the Terraform step and stored in Vault. And it uses that then to be able to run Ansible against itself. So the end result is that it takes about 15 minutes to provision a fully working server from end to end for us in our environment. So when we have a new user, for example, it will take us about 15 minutes to provision a new user for them or a new server. So in choosing or in coming up with our solution, we had obviously some obstacles to overcome. One of the biggest problems was deciding what desktop we should actually support on CentOS or Red Hat 7. So when we went from Red Hat 5 onto the 7 branch, the GNOME desktop got updated to GNOME 3, I suppose it is, because it used to be GNOME 2. And it just looks nothing like what the users were used to. But luckily there is the Mate desktop, which looks a lot more familiar with someone who came from GNOME 2 maybe. So we support both Mate and GNOME, and also XFCE and i3. i3 is a great window manager, even though it is very hard to learn, but once you've learned it, it's great for switching between text consoles. So all us Linux engineers, we all seem to sit in i3 all day. Another big obstacle was to automate the actual install. So we have several environments. All the different hedge funds have slightly different setups, and we had to be able to make ThinLinc run through Ansible and basically set up the environment correctly for that particular hedge fund and for that particular user. And in the end, we settled on generating an answers type file for the installer. And that then gets piped into the installer at build time, and it basically installs ThinLinc. Another big problem we came across was user inertia. A lot of people really liked running their Red Hat 5 desktop because they were used to it, and they knew where all the things were, and they could customize it, etc. So in actual fact, like, the main problems that we came across weren't actually technical. It was more a people problem, getting people to actually switch to CentOS 7. Because we had, well, first of all, there was the UI that was different, but also we had changed the clustering technologies underneath it. For example, we run something called Slurm occasionally, or we used to run Slurm, and we changed Slurm versions, and they went onto a different cluster, all the jobs, and that was a bit difficult for users to comprehend to begin with. And actually, one interesting thing about ThinLinc, and actually I think Linux desktops in general, is that a lot of the software is designed in such a way that it redraws large portions of the screen, which works fine if you're on, like, if you have a local workstation and you have a local screen connected to it, everything works great and it looks really nice. However, when it comes to displaying this screen over the network, things or software such as PyCharm and PyDev and Eclipse in particular, they seem to redraw large parts of the screen when they do syntax highlighting, for example, or when someone clicks a menu, the menu, it's quite a heavy operation. So we had to figure out some way of overcoming that, obviously, without or because otherwise the desktop was too slow to use, basically. And the easiest way to do that was to turn on power saving mode in PyCharm and Eclipse, and that basically disables a lot of the eye candy that you don't really notice anyway, but it also lets you, well, it becomes fast enough to use. So in conclusion then, ThinLinc allows us to publish desktops to researchers or to all our users as well, with minimal issues. And it's almost as good as having a real Linux workstation, because, for example, you can do multiple monitoring spanning. So if you're at home or you're in the office and you have multiple monitors, you can span it across all the monitors. You can run in full screen mode. It's like having a Linux desktop locally. The automation is not terribly difficult, and Sendio itself is a small company that is easy to deal with, really. So we are very happy with it at the moment. And that is the end of my presentation. If anyone has any questions, I'm happy to answer them.
Thank you very much, Bilar. We have a couple of questions here, so by the social network. So the first one, what do you mean about reasonable cost?
About what, sorry?
Reasonable cost.
Oh, I see.
No?
So obviously you can run the open source version of ThinLinc, and it lets you run, I think, 5 concurrent users. But we have about I think 300 ThinLinc licenses at the moment, and when we compared that to, for example, No Machine and other commercial offerings, it was I mean, it's a much lower cost, really.
Okay. The other question is about the in time for all a small company. What time to implement?
So we've only had a couple of support requests, really. For example, like the GNOME crashed. In fact, actually, so when we first started using ThinLinc, it also crashed in the same GNOME library that all other VNC servers. And then we spoke to them, and they implemented a fix in a couple of days. And they're really responsive in asking for the right information, and they can sort of, I don't know, like, it feels like they can ask you questions at the right level, if that makes sense.
Yes, yes. There are another one. Some users are comfortable with AirHill. It is fine to maintain the change for everybody. Is there something additional we user must learn?
I'm sorry, say again.
Some users are comfortable with AirHill.
Oh, okay, yes.
Yeah. Is it fine to maintain the change for everybody? Is there something additional we user must learn?
No, so I think, so we used to use Red Hat 5, right? But then when we moved, I think when we used Red Hat 5 as well, I think CentOS maybe wasn't quite as mature, or we had already bought a lot of Red Hat 5 licenses anyway. So when we switched to Red Hat 7 and CentOS 7, we decided to switch to basically CentOS 7 on the Linux desktops. And really, in terms of a user experience, I wouldn't say there's any difference. And especially if you install something like the Mate desktop, it's nice and easy to use.
Okay, so thank you very much, Henrik. A pleasure to have here in Carla 2020. Okay.
Thank you.
Thank you. So, Francisco, it's your time.
Thank you. Thanks, Henrik, for the presentation, for the great presentation.